All right, lesson 312. We're going to look at today rewriting trigonometric expressions in equivalent forms using trigonometric identities. I know a lot of times I start scratching on this page to show you what's going on. Rather than that, take a look at your next slide. On your next slide, we have listed the first set of trigonometric identities. These identities right here, you have to have these memorized. Hear me. You have to have these memorized. You cannot succeed long term if you don't have these memorized. So up here we have a lot of different formulas down. I'm going to kind of walk them through in a brief way. The co-function identities, what this does, before you get lost in all the math up here, what this does is it changes a sine function to a cosine function or a cosine into a sine. What does it change? Sine to cosine or cosine to sine. It changes a tangent to a cotangent or a cotangent to a tangent. It changes a secant to a cosecant or a cosecant to a secant. I'm going to call these three different families: the sine family, the tangent family, and the secant family. What a cofunction identity does is it changes it from a sine to a cosine or a cosine to a sine. The only difference in these words that I'm saying is one has a co and one does not. Make sense? Do you hear me? One has a co, one does not. So tangent becomes a cotangent, and cotangent becomes a tangent. I'm only hearing one student. What's going on? Let's try that again. Secant becomes a cosecant, and cosecant becomes a secant. Now I'm going to explain what this is. Pi over 2. I want you to think on the unit circle. Where does pi over 2 exist from? Where is pi over 2 in the unit circle? It's on the y-axis. What happens if you have an angle that's negative? Which way do you move? Clockwise or counterclockwise? Counter. Let me explain this to you by way of picture. Whoops. By way of picture, I'm going to use this graph here. Now on this, again, I know I can't zoom it in any further than it is without it becoming blurry. So scoot closer to the screen if you need to. This green dash line is called anybody see that right there? The tangent line. A tangent line is anything, the definition of tangent, it says right here, is to touch. The tangent line, what does it do to the circle? It touches. Now here's the relationship between tangent and cotangent. Tangent is the distance from where that touches the circle to the x-axis. Hear me, to the x-axis. So what does its cofunction do? If tangent measures from where it touches to the x-axis, the cotangent measures from where it touches to the y-axis. Okay, now let me go back to the formula. This will make a little bit more sense. Cotangent starts at the y-axis, which is pi over 2, and it moves like a clock. Whereas tangent starts at the x-axis and goes counterclockwise. Make sense? Now, mathematically, it's also true if you switch it around, but this is the true relationship right here that I just showed you. This right here is the relationship I just showed you on that page that visually is accurate. That tangent starts where does tangent start? The x-axis, which is like 0, and then it moves clockwise, which would be you adding theta. 0 plus theta is theta. That's why it just says a theta there. Cotangent starts at, what's pi over 2 represent? The y, and it moves counterclockwise. That's what this picture is showing you here. Tangent starts at 0 and it moves like against the clock. Does that make sense? Hey, you got to talk to me so I know. Where does tangent start from? The x-axis, and it moves like a clock. Where does cotangent start from? The y, which is pi over 2, and it moves against the clock. Make sense? Okay, now, as your point moves, tangent either gets longer or shorter, and as tangent gets longer or shorter, cotangent does the opposite. Make sense? So here, tangent would be very, very small, but cotangent is very large. But if I adjust it this way, now tangent is very small, and cotangent small, and now tangent is large. Making sense how this works? Okay, let's talk about secant. The word secant means to cut. There's three families. I said the tangent family, which means to touch. Secant means to cut. This here in purple is the secant line. The secant line, and from Algebra 1, lines mean they go on forever. A secant line cuts the circle in half. If it's a secant, it cuts the circle in half on the x-axis. Remember how tangent went to the x, cotangent went to the y? Secant cuts the circle in half on the x-axis. What do you think cosecant does? Cuts it in half on the y. By definition, the length of secant is from the origin to the intersection with the tangent line. So from this point there to this point there, that's actually the length of secant. Oh, it looks like secant is a perfect 2 units. Wow, what a lucky guess. Oh, I just randomly did that. You see how long is it from 0, 0 to 2, 0? 2. If you go up here, I had the calculator show you. Look what it says secant is right there in the table. It says secant equals 2. And that's how they measure it. That's where they would come up with the values. So secant is on the x-axis. Cosecant is on the y-axis. So what am I showing you over here? This would represent, let me find it, where secant starts on the x-axis. That means 0 plus theta in this, you know what I'm saying? And the cosecant starts where? The y-axis and moves against the clock. Make sense? Now, it's true mathematically if you switch them around as well, but that's what I just showed you. Now, let's talk about sine. Tangent means to cut. No, I said that wrong. Tangent doesn't mean to cut. Tangent means to touch. Secant means to cut. Sine means to connect. Sine connects the tangent line and the secant line, and it does so at the point of tangency. So wherever that point is, sine connects those two values. Does that make sense? Now, sine, it's going up and down. So what is that actually measuring? X's or Y's if it goes up and down? Say Y's. It's measuring Y values. Sine is measuring Y. Sine is Y. Cos is X. Okay, but when you look at it visually, sine, though it's measuring Y's, it actually connects to the X-axis. Its cosine connects to the Y-axis. Therefore, the true relationship is shown right here, that sine starting at the x-axis and moving against the clock is equal to cosine starting at the y-axis and moving counterclockwise. That's what cofunctions are. Cofunctions switch you from a sine to a cosine or a tangent to a cotangent and such. Make sense? Okay, that's the first one you have to memorize. Second is even and odd. We talked about this last class. What this means by definition, it's harder to understand this way. Let me write it this way. If something is odd, when you compare, whoops, I meant to do a comma. If something is odd, when you compare opposite x's, what happens to the y's? If you compare opposite x's, what happens to the y's? If it's odd, O's go together. Opposite x's produce opposite y's. So you might have a positive y and then a negative y. So on. Thank you. That's what odd is. This is odd right here. Go ahead and make a mark. Sine is odd. Sine is odd. Cosecant is odd. Tangent is odd. And cotangent is odd. Those are odd because if they have a y in their ratio, then the y's will be opposite. So that leaves 2 left over. What do you think those two are going to be? Even. Mark that those two are even. Cosine and secant are even. They do not have a y, therefore the y's won't change. The y's will be the same. These two are even. Okay, that's how I showed you last class. I have not shown you the Pythagorean identity. You're about to learn that today. Quotient, you actually know quotient. Sine is y, cos is x, tangent is y over x. Okay, let me say this again. Now that I wrote tangent is y over x. Sine is what? Y. Cos is x. On the unit circle, it's just that. Obviously, if it's not a unit circle, you throw in the letters r, but it'll still mathematically work. If tangent is y over x, what's cotangent? X over y. Let's do this again. Cos is x, sine is y. You probably already know that one. Probably don't have to memorize that. What we also learned last class on lesson 311 are the reciprocals. Okay, this is where you switch families. So there's 3 families of functions. There's the tangent family, there's the sine family, there's the secant family. How many families are there? 3. Sine switches to the secant family by a reciprocal. Secant switches to a sine by a reciprocal. Tangent and cotangent do not switch families by reciprocal. They switch families by this quotient. That's how they switch. Tangent switches to this sine family. What am I trying to say? Using the reciprocals, you can switch families. This is a sine family. It's equal to 1 over What does CSC mean? Not cosine. Yeah, CSC stands for cosecant. Sine family switches to the cosecant family. Here's the trick to get these down. Here's your big trick. You will only have one co. You will always have one function that's a co and one that's not. You'll never have two co-functions. That would be coco. All right, dumb joke. Only got one little laugh. You will only have one that's co. What do I mean? This is a sine. What is this? Cosecant. How many cos do we have there? One. Okay, this time, this is a cosecant. It would switch families by reciprocal to the sine family. If this is a cosecant, then it would be equal to a cosine? No, it would be equal to a sine. You won't have two cos. That would be coco. I'm just trying to give you a mental technique. Okay, how about cosine? If you have a cosine, that's the sine family. When it switches by reciprocal to the secant family, does it keep the co or lose the co? Lose it. So cosine is equal to 1 over secant. That's how you switch families. Secant does not have a co, so when you switch it to the sine family, it becomes a cosine. By reciprocals, tangent does not switch families, it just switches from tangent to 1 over cotangent or vice versa. If you want to switch tangents families, you use this identity. Okay, with all of that, we're going to start on today. You are in for a surprise. Some people will say this is their very favorite lesson of the year. Most would say their most forgettable lesson of the year. We'll see what your opinion is shortly. Example 1. It says here, simplify each expression to a single trigonometric function using trigonometric identities. Here's our goal. We want to simplify these to a single. That means one trig function. So right now, how many trig functions are there? We go. How many trig functions are there? Right here. 2. Perfect. How many do we have to simplify it to? 1. Here's our trick today. The trick is you first try to change all trigonometric functions into the sine or cosine family. And you might be going, wait, what does that even mean? Well, I'll show you. So that's our first step that we're going to try, what we're going to do. So first, when I ask you, this is a symbol for alpha, the letter A, Greek. Sine, is that already in the sine family? Yes. So we're not going to do anything with sine. And I'm going to write just a normal A. Alphas are hard for me to write. So that does not change. That stays the same. However, secant will change. Secant is not in the sine family. How do you change a secant into the sine family? Well, how to switch family is as you use reciprocals. David, you got to follow today. You got to put that up and be writing along, please. You have to use a reciprocal to switch families. When you change from secant to the sine family, you use a reciprocal. That's what I'm doing here. I tried to give you a mental technique so you remember this. What happens when you change a secant to a sine family? Does it go straight to sine or does it become cosine? It becomes cosine. How do you remember that? You need to have one co. You don't have two cos. You don't have zero cos. You have to have one co. Does secant have a co? I'm going to say that again. Does secant have a co here? No. So when you change it to the sine family, it needs to be cosine. That right there, what I just did, that would be called a reciprocal identity. If you want to write that down so you can look back in the notes, that's where you would see that on that cheat sheet. That was called a reciprocal. That's not how you spell identity. Let's try this again. Identity. Okay, let's do the math. This says to multiply. What is sine times 1? So it's just sine A, sine alpha, over cosine alpha. So I'm still not done. It says change it to a single trig function. That's 2 trig functions. So what could I do now? This says sine divided by cosine. How could I change that to a single trig function? Wait a minute, that was one of our identities. Think about it. Sine is what letter? Sine is y. This is y over x. What is y over x equal to? Tangent, and we're done. Tangent's going to be our solution. This right here is tangent. Now, to do that substitution there, that substitution is called a quotient identity. That right there was called a quotient identity. You do not have to know these names by heart, but I am writing them there so that if you look back on your notes on that cheat sheet, you'll be able to find them. That relationship is found on quotient identity, that tangent is sine over cosine. And I also did a reciprocal. I did that secant was equal to 1 divided by cosine right down there in the middle of the screen. I used those two identities to solve that problem. That's what today's lesson is all about. So now that you've seen me do it once, let's see me do it a second time. How many trig functions do you see right here? 2. Right now, these two are multiplying with each other. What is the first step you can try to solve these problems? Change it to the sine and cosine family. Okay, is cosine good? Yes, this just stays. This is already in the sine family. Cosine is part of the sine family. I put sine or cosine family so you follow along later. That stays the same, and that's like a b. It's a beta, technically in Greek. Okay, let's talk about tangent. Is tangent in the sine and cosine family? No, so we have to exchange it somehow. How do I make tangent become a sine and cosine family? Sine divided by cosine. Perfect. Sine divided by cosine. That right there is called a quotient identity. Quotient identity is how you change your tangents and cotangents to the sine and cosine family. Okay, what do you think you could do now? Cancel. Perfect, David. Perfect, Naeli. What cancels here? These are multiplying. The cosine's dividing. Oh, wait. I'm multiplying and I am dividing. What am I left with? And this would be the final answer. Now, why is that the final answer? It's a single trig function. Does that make sense? Okay, that was, I made these, I'll call them basic problems. Those are very basic, just to walk you through the steps that we're looking at today. Let's go to example 2. Oh, wait, no, I have a C. Sorry, I have a C. Let's start fresh and do this again. All right, what's our first step? Change the sine and cosine family. What about sine squared? Is sine squared in the right family or is it not in the right family? Right family, leave that alone. Sine squared, and this one's a theta, so sine squared theta. Doesn't matter what your variable is, you do the math the same way, whether it's an alpha, a beta, or in this case, a theta, doesn't matter. Okay. Secant, is that in the sine and cosine family? So we have to change it. How do you change from the secant family to the sine family? What's the word though? To change reciprocal. The change from the secant family to the sine family comes by reciprocal. Now, when you go to reciprocal, I want you to think a secant becomes a sine or a cosine? Cosine. Some of you are catching on quick. What do you think about to know which one it is? Whether or not secant has a co. Does secant have a co? No. So when you take its reciprocal, it gains the co. Okay, now, next one, that's called the reciprocal identity right there. That's what that's called. If you want to look back, where did I find that? That would be under the reciprocal identities. That's what that is. Okay, now tell me about cosecant. Is cosecant in the sine and cosine family? So what do we do? Change it. How do you change a cosecant into the sine family? Reciprocal. It's going to become 1 over. Now, when you change a cosecant, does it become a sine or a cosine? It's a sine. It can't become a cosine. That would be coco. That's, again, I know it sounds dumb. It's cheesy. Well, guess what? I'm a dad of 5 kids. I can make dad jokes. Okay, I'm allowed to. I'm qualified. That's a little cheesy dad joke, but hopefully you'll remember it. You can't go co to a co. That would be coco. So what do you do if it was a co? You drop the co, and so it becomes just a sine. Make sense? That's how you switch from a secant family to a sine family. All right, now let's do the math. Let me write that. That was a reciprocal identity as well. What math would happen here? We would multiply and also divide by sum, but something can happen on this math. Sine squared is multiplying. This sine is dividing. What can I do with multiplication and division when they both involve a sign? Cancel. They're opposites. This sign will cancel this squared. It'll cancel one of those signs out. Is that, you follow? Okay, so we're gonna multiply. What's sine times 1? Sine times this one. Sine. It's still sine. And then in the denominator, all that's left over is cosine. I'd like to say we're done. We're not. That's 2 trig functions. It's not a single trig function. It's 2. We have 1 step left. I have a sine over cosine. They're both in the sine family. It's a recognition that this is actually an identity. Right here. This is y divided by x. What is y divided by x? Tangent. That right there equals tangent. And just like that, we have our solution. Tangent is the solution here. Does anybody remember the name that takes from this to that? That's called a quotient. Good. A quotient means the answer to division. The answer to dividing a sine divided by a cosine is tangent. That's why they call it a quotient. It's because you're dividing a sine by a cosine. Or if you flipped it, a cosine divided by a sine, it would be cotangent, but it'd still be called a quotient identity because you're dividing sines by cosines. That's why they call it quotient. Questions over that? So do you kind of have an idea what we're doing today? Okay, now what I'm going to do is I'm just going to jump and put the difficulty all the way up. I'm going to turn it up from 100. So right here, I would say the difficulty here, I'll call it about a 40 or 50. That was the difficulty. This is like half difficulty. I'm going to turn it all the way up to 100. To do so, what I'm going to do is I'm going to give you the start of the problem and the final solution. Today I'm going to give you the start and I'm going to give you the final, because ultimately what's going to happen when you take your exams is it's going to be multiple choice on this part. You're going to know where you start and you're going to have 4 different final solutions as possibilities. Does that make sense? You're going to have to figure out how to get from one to the other. Today, it would just be too difficult if I did not give you the final. If you didn't know where I was going on all of the problems, it would just be too difficult to know, wait, when do I stop, when do I not? Because not everything's going to become one single trig function. So what I'm going to do today is it's going to be like, here's the problem you would see, and this would be one of the answer choices. Let's figure out how we get there. Does that make sense? Okay, with that, what's the first step we do? Change the sines and cosines. I'm going to break this apart, and I'm going to do it 1 divided by tan. I don't like fractions. Do y'all like fractions? I'm going to drop the fraction first. This is a 1 divided by tangent. That's a reciprocal. I just added the 1, doesn't change anything. What is 1 divided by tangent equal to? That's a reciprocal. 1 divided by tangent is 1 over tangent is equal to, I think I hear some people, 1 over tangent is what? Cotangent. It's cotangent. So 1 over tangent is the same thing as cotangent. That's cotangent A. Okay, that's that part. Times, I'm going to leave secant alone for a second. I want to do it step by step. So I leave the secant alone. I didn't change the secant. That right there is called a reciprocal identity. I want to work down this time rather than across. Are you tracking with so far what I've done? The secant stayed as it was. 1 over tangent became cotangent. Now, let's change to sines and cosines. Change to the sine family. That's the easiest way to cancel everything out. Now that my fraction's gone, I can do that. Tangent, cotangent. What is cotangent in terms of sines and cosines? It's cosine divided by sine. Very good. Cosine divided by sine. David, that's great. Y'all, do you remember what the name is for that? Maybe I should just start writing quotient and then ID or something like that for shorter. Okay, what about secant squared? That's not the sine family. How do I change it to the sine family? Reciprocal, good. To change from the secant family to the, sorry, lost my train of thought. To change from the secant family to the sine family, it's by reciprocal. What is the reciprocal that secant squared would become? Does it become a sine squared or a cosine squared? Cosine squared. How do y'all remember that? You need 1a. I mean, 1a. You need one cosine. You need one co. Goodness gracious, I can't talk. You need one co. That's called a reciprocal identity. Okay, we're actually almost done here. We are so close to having the answer. Now that I changed this form, we can come up with the answer real quick. What do you see that happens? This cosine cancels with one of those with one of those cosines. You see how those cancel out? So that's just a 1 on the top. That's easy. Okay. And then I have a sine times a cosine. So sine times cosine. That's just by algebra I did that. Now I have a question for you. Do you know what 1 divided by cosine is? That's secant. Actually, I'm going to write it in the way we have it. What's 1 over sine equal to? Cosecant. Okay, 1 over sine is cosecant. What's 1 over cosine? Secant. This becomes cosecant times secant. And those are reciprocal identities, which is the same thing that they gave us at the start. That is right there, reciprocal identities. Both of those were that I just did. I'm going to write identities this time because we did it twice. That right there is your answer. So we just verified. Usually with verifying, they make you do like a check mark. That right there is exactly what we were supposed to get. The only thing is that order is different. But order doesn't matter when you multiply. Just to use easy numbers, what's 2 times 5? 10. What if we switched the order when you multiply? What if we did 5 times 2? What do you still get? 10. When you multiply, order doesn't matter. And so that's why you get the same thing. All right, let's take a look at example 2b. Here, again, here's the start. Here's the start. And if you were taking the exam, here would be your option. This would be one of the 4 options. Actually, this is a typo. Put a negative in there. It needs to be negative cosine squared. Okay. What do we do first? We want to change the sine and cosine family. What I'm going to do, I don't like fractions. Are y'all with me? Do you like fractions? The first focus I'm going to put on is getting rid of this fraction. To get rid of it, I want to put a 1 times up here like this. Technically, it would need to be a parenthesis because it would distribute, but either way, like that. I want to do just that. I have 1 over cosecant. I can change it to the sine family by doing a reciprocal. 1 over cosecant is going to become sine. Very good. You're getting faster. That becomes a sine. 1 over cosecant becomes sine. Now, this needs to multiply times all of this. I'm going to copy the rest down. Let me just leave that in black so you can see that nothing changed there. It's going to multiply with sine x minus cosecant x. That's that part. I did not change that. What's it called when you do a 1 over a trig function to something else? When you change families, what's the name of that? Reciprocal. Good. Reciprocal. You don't have to know the names, by the way. I'm just teaching you the names because I want you to be the best. The best. Better than all the rest. Isn't that how the song goes? Okay, now, what will we do next? We could change cosecant, or you could distribute, either one, whatever you feel confident. Y'all said change to cosecant. What is cosecant the same thing as? Wait, we got to change families. How do you change families? You just got to become 1 over. And a cosecant, to change it to the sine family, does it keep the co? Does it become co-co? No, what happens? Loses the co. So it's therefore a... Okay. That right there was another reciprocal identity. Okay, what do you think you could do next? Distribute. So we're doing a little algebra now. Sine times sine becomes sine squared. And by the way, you don't actually square the x. The x would refer to the angle. You're squaring the sine, not the angles, just to know, so you know where the squared goes. Okay, now when I multiply here, it becomes minus sine times 1 is sine, so it'd be sine divided by sine. What's sine divided by sine? 1. Just like David said, that was just straight up algebra right there. Okay, now our last step. This is I have not taught you. So now let me do this. Whenever you see a squared and a 1, or hear me, if you see two squares, what am I talking about when I say squares? Am I talking about the shape of a square? I'm talking about the power. If you see two squares or you see a square and a 1, you're going to do the Pythagorean identity. Let me show you how it works. On the side, I'm going to write the Pythagorean theorem. Go ahead and do this with me. You do the Pythagorean theorem. In my class, I don't say a squared plus b squared equals c squared. What do I say instead? What variables do we use? X squared plus y squared equals r squared. Perfect. If you see a squared and a 1, it doesn't matter which trig functions you see. If you see two squares that are adding and subtracting, or you see a squared and a 1, you're going to do the Pythagorean identity. How do you get to the identities? You don't have to memorize them from the previous slide. You just need to memorize this and know what your ratios are. What is sine's ratio by itself? Y over r. So sine squared is y squared over r squared. So here's how you figure out what this will become. You go to your Pythagorean identity and say, okay, this is y squared over r squared. So I need this to be y squared over r squared. The rule of math. If I'm going to divide this by r squared, I have to divide everything by r squared. You follow? And this will give me my Pythagorean theorem that was on the Pythagorean identity that was on the front page. What is x over r? X over r was which ratio? Stay with me, Sanaya. X over r was cosine. So x squared over r squared is cosine squared. The variable here is x, so I'll put an x in. Don't get confused with this x. It's different than that x. That's just that variable right there. Plus, which trig function is y over r? Sine. So y squared over r squared would be sine squared. And again, my variable here is x. It'd be less confusing if I chose a different one. Now finally, what is r squared divided by r squared? 1. This right here is just a manipulation of this identity right there. If I were going to have sine squared minus 1, I just need to manipulate this. So you see how it says sine squared minus 1? I would need to have a minus 1. Now if I minus 1 on the left, I got a minus 1 on the right. Make sense? So I would have a cosine squared plus a sine squared minus 1 equals 0. And last step to figure out what this is, I needed to isolate the sine squared minus 1. I needed to say only sine squared minus 1. How to get rid of a positive cosine? That's adding. We would subtract cosine. So I would subtract cosine. Oh, it's cosine squared, I should say. So now, we just discovered what does sine squared minus 1, what's that going to equal? And that's our answer. That right there, we just did it, we verified it. So technically you do a check mark, but that would be your answer right there. We did it, and that was called the Pythagorean identity. Okay, so Pythagorean identities are a little bit tricky because you might have to manipulate them. But where they come from is the Pythagorean theorem. You choose by the ratio given what to divide the Pythagorean theorem by, and that's how you get to do that. Okay, so that's Pythagorean identity. That went from here to there. That's what that was. To go from here to there, that was the Pythagorean identity. All right, I'm going to do, I think there's one more, and then we'll go try some on the back. Okay, walk me through one more time. Again, here's the start. This is the finish. So on the test, you would only see the start, the finish, or here's the final right here. This would be one of the 4 answer choices. Let's walk through. what would you do first? Change everything to the sine family. It's the easiest way to start. Okay, sine, good or bad? Good. So we have sine B, sine beta. Tangent, good or bad? Bad. We're going to change that. It's multiplying, so we'll do multiplying. To change tangent into the sine family, it's y over x, therefore it is sine divided by cosine. Cosine, is that good family or bad? Good. That stays the same. So you just bring that straight down. So the only thing I did there, this is not a reciprocal. Do y'all remember what this one's called? Quotient. That's the only thing we did this time is the quotient identity. Now what do you think happens? Oh, you haven't seen this before. Okay, I could simplify. What's a sine times a sine? Sine squared. So it'll be sine squared over cos plus cos. This right here, you need a common denominator, algebra. To add and subtract, if there's a fraction, you have to have a common denominator. What's my denominator on the left? Cos. I need to create a common denominator. So I'm going to do a cos over here times a cos. Ultimately, what I'm doing is I'm multiplying by a funny looking one, but you see how it gets me a common denominator? So that's what this is here. On this side, it's a common denominator. I forgot the second M. There we go. Common denominator. Denominator. There we go. Spelling's not my best subject. Okay, do I have a common denominator? Yes. So I can write this as one fraction now. This would be cosine. And then in the numerator, I have a sine times a sine. What's sine times sine? Plus cosine times a cosine. Great. Now, what do you think you could do next? Can't cancel the squares.
You cancel the cos.
Can't cancel this one with this one because they're adding. If they're multiplying, you could. So I haven't made it clear yet. So the first strategy when we solve is we change everything to the sine family. That's the first strategy. The second thing you need to be looking for as you go through is you look for two squareds or you look for a squared and a 1. Remember that? You either look for a squared and a plus or minus 1, or you look for two squareds. What do you see at this stage? If you see two squareds, that's telling you I got to pause and I need to do the Pythagorean. So the Pythagorean, so you don't have to memorize so much. I just stick with the Pythagorean theorem. What is the Pythagorean theorem? Okay. Over here, you pick one of your squares. It doesn't matter which one you pick. Which one do you want to pick? Sine? What's sine's ratio? Okay, you want to pick cosine? What's cosine's ratio? X over r. So if it's cosine squared, that means it's x squared over r squared. We need to turn that into the same thing. So I see x squared. I need to make it x squared over r squared. Rule of math. If I'm going to divide one thing by r squared, what do I have to do with the rest of the problem? Everything gets divided by r squared. Okay, let's simplify. What is x squared over r squared? You've already told me once. That will be cosine squared. They use the letter b here, so I'm going to do cosine b plus, very good, that's quick. Y over r is sine, so y squared over r squared must be sine squared. What's r squared divided by r squared? 1. Okay, there it is. Now check out what I have. I have sine squared plus cosine squared. Look what I have right here. Well, you see how it's the same thing? Cosine squared plus sine squared is the same thing as sine squared plus cosine. The order when you add does not matter either. So I could change that and say this is 1 over cosine. Oh, I see why you said that now, David. I got you. That right there is the Pythagorean identity. Changing the numerator here to the numerator there, that was the Pythagorean identity. We change the numerator of sine squared b plus cosine squared b to the number 1. That's what we call Pythagorean identity. Okay, and so now we're on our last step and we'll be done. This is a single trig function, but it's 1 over. So you want to leave it as a reciprocal. What's the reciprocal of cosine? Secant, good. It changes to the secant family, and you drop the co, because it would not, whoops, I started right, secant. Cosine b, that, secant b, that would be your answer there. Which when they say the word verify, this one actually didn't say it up there. You technically do a check mark, but there it is. And what's that called when you change 1 over cosine to a secant? That's called a reciprocal identity. That right there is a reciprocal identity. Wow. So you've seen me now practice, I don't know, what is that, 6 of those I've now done? I think example 1, ABC, and now example 2, ABC. I think it's time for you to practice one. I'm going to leave this alone. We're going to try DOL number 3 in the back of your packet. Go to your back of your packet. Go try DOL number 3. All right, it's time to start example 3. Before I get into example 3, what example 3 has to do with is sometimes we have things going on with the input. So far today, all I've done is the identities that have to do with the trig ratios themselves, like how did the sine become a secant family and stuff like that. What I'm going to deal with in here is what happens when the input has been adjusted. What you need to have memorized, honestly, if you memorize this formula right here, these two, you can actually come up with the rest of the slide all on your own. Now, I left all of these, so if you're doing delta math and it shows you one, you can come up with the answer pretty quickly. But honestly, if you memorize this right here, these two right there, if you memorize those two, you can memorize, that's the whole page. Just like I was saying on Pythagorean identities, don't mess around with memorizing that whole list. Just know your Pythagorean theorem, and you can figure out the rest. Same idea here. If you know these two formulas right there, you can figure out the rest, okay? Make sure you make a mark on that. You have to memorize that formula. That right there you need to memorize. I'll go ahead and say it, or I'll write it, I mean. Memorize. You need to memorize this page. Not this page, I'm sorry, these two formulas, okay? So what does this mean? Let's say you're on the non-calculator side of your test, and you're asked to evaluate sine of 5 pi over 12. Without a calculator, I told you everything will be a hand trick. So let's take our hand. Which side's the pi side? The palm or the back? Palm. Look at your palm. Let's bend our pi over 12 finger. Uh-oh, we don't have a pi over 12 finger, do we? Okay, there's a formula to make this work. Here's what you do. You take your value and you put it by pi over 12. You take your input, and what we're going to do is we're going to rewrite our input as two different inputs of pi over 12. And here are the rules. You're going to pick two different numerators. They must add up to 5. Number 1, they must add up to 5. And number 2, they must be able to reduce with 12. So let me give you some examples that would not work. I could not pick the numbers 8 plus 9. I could not pick 8 plus 9. Why could I not pick 8 plus 9? They don't add up to be 5. Here's another one that would not work. I could not do 1 and 4. They do add up to 5, but 1 does not reduce with 12, and it doesn't solve my problem. I would still have a pi over 12. What I need to pick are two numbers that add up to be 5, but can go into 12. Have y'all thought of what they are yet? How about 3 and 2? Perfect. Now you can write this down. Now I will simplify our two angles, and we will be able to use our hand trick to solve sine of 5 pi over 12. 3 goes into 12. How many times? Both of these will reduce. That becomes pi over 4. Good. 3 pi over 12 is the same thing as 1 pi over 4. Perfect. Now how about 2 pi over 12? That could be reduced to become pi over 6. So over here, to find 5 pi over 12, what I'm going to do is I'm going to add pi over 6 with pi over 4. If I add up these two angles, this was technically going to be angle A. This one's angle B. If I add those two together, I can get 5 pi over 12. So here's the formula. You write sine, instead of 5 pi over 12, I'm going to put it as pi over 4 plus pi over 6. Okay, so now that I've rewritten that, I now can find sine 5 pi over 12 using my hand trick. So here's what the formula was. It was on the previous slide. It's the one I told you you had to memorize. Sine, what happens whenever you're adding two angles like this? The formula says that sines, we'll take the sine of angle A. Okay, I'm going to call this A and this B, just to be clear. If I say A and B, that's what I'm talking about, A and B. You take sine of A, and it multiplies times cosine of B. So sine A times cos B, and then sine's symbol will stay the same. Notice the alliteration. I'll say it again. Sine's symbol will stay the same. You put a plus in the middle, and then the second time around, it's still A and B, but this time we do cosine of A times the sine of B. Times the sine of B. And now we'll use hand trick to simplify these. Okay, so we're doing pi over 4 first. Which finger is your pi over 4 finger? Middle finger. Let's bend our middle finger. To evaluate sine, you need to flip your hand over. How many y's do you have there? 2. How many x's do you have there? 2. Okay, so you told me there are 2 y fingers, so go under sine of pi over 4. If we have 2 y fingers, it should be the square root of 2. On the hand trick, your r is always 2, so put it over 2. R is always 2 in the hand trick. So we had 2 y fingers, and we had 2 x fingers. I'm going to go ahead and put cosine of pi over 4. I'm going to, cosine of pi over 4. I'm going to put its value as well. Okay, which leaves us with, now we need to find the cosine of pi over 6 and the sine of pi over 6. So go back to your hand. Which side is the pi side, the palm or the back of your hand? Palm. Find pi over 6. Then your ring finger. To evaluate cosine and sine, what do you do to your hand? Flip it over. Once you flip it over, you can get rid of the sine and cosine. They're gone. Cosine is x. How many x fingers do you have there? So 3 x fingers, that means it's square root of 3. What is r always on the hand trick? 2. Good. Over here, sine. How many y fingers do you have at that same location? 1. And again, r is always 2. With these values, notice I have a common denominator. What's 2 times 2 over here on the left side? 4. What's 2 times 2 on the right side? 4. You will have a common denominator every time we do this formula. In the numerator, what's the square root of 2 times the square root of 6? I'm sorry, I just gave you the answer. What's the square root of 2 times square root of 3? Square root of 6. You're allowed to multiply square roots. You are not allowed to add square roots. So you just have to leave them separate. What's the square root of 2 times the square root of 1? Not 3, that would be adding. Square root of 2. That right there is our solution. Yep. Now, the one thing I did not talk about on this that you would need to identify for A and B, tell me about the x's. Were the x's positive or negative for A? Positive. What about for B? Are my x's positive or negative? Positive. What about my y's? They were both positive. We do have to keep that in mind because if you happen to have values that you pick that are negative, whenever we do the hand trick, we would need to include the negatives. Okay, I'll show you that now on part B. So I'm going to leave that over there. Both of these had positive x's and positive y's. Okay, now let's try part B. So I'm going to let you see it again. This time I'm doing cosine of 17 pi over 12. So let's think about 17 pi over 12. Do we have a finger for that? No. So what you would do is you will use that formula. You need to come up with two numbers that add to be 17 and both go into the number 12. So throw out an option that would not work. 1 and 17 would not work. 1 and 17 because when you add them, do they give you 17? No. So those would be bad. 1 and 16 would not work either because even though they add to be 17, 1 does not simplify with 12. So throw out a different option that you think might work. How about 2 and what number would go here? If you chose a 2, what has to go here? 15. These will actually work because 2 goes into 12 how many times? 6. That's pi over 6. That will be our A. And then a number goes into both 15 and 12. What goes into both? What value? What number goes into both 15 and 12? 3. You could change this to 5 pi over 3 goes into 12. How many times? 3 goes into 12 4 times. This will be angle B. So I'm going to come over to my little chart to help me out. Angle A is again pi over 6. We already had that. So this next time, this is going to be A. Again, that's a positive x and positive y, but 5 pi over 4 is over here. When we evaluate 5 pi over 4, we need to notice that that will have a positive or negative x. A negative x, and what kind of y? Negative y. That's going to have, we'll see that as we go. Okay, so we're looking for cosine of 17 pi over 12. We're going to use cosine of pi over 6 plus 5 pi over 4. That's what I'm actually going to be finding. I'm going to call this A and this B. So that I can write more linearly, I'm going to write this off to the side. I'm going to move this over here. Okay, so I want to pick up. So here's how cosine's formula works. I told you last time sine stays the same, the symbol. Cosine's not that way. Cosine, its formula will change. So its symbol will change. So sine's symbol will stay the same. This is how to memorize it. Sine's symbol stays the same. Cosine's going to change. So it's going to go pi over 6. The other thing cosine does different is it does both cosines back to back. So it's cosine A, cosine B, and then it changes. Instead of it having a plus, what does it do instead? Minus, and it'll be sine A, sine B. Again, you have those formulas that you can look back at, but these are what you have to have memorized to find success in my class. Pi over 4. Yep, pi over 4. Sorry. Pi over 4. Pi over 4. There we go. Okay, good correction. Thank you. So sine symbol stays the same. Cosine changes. Sine also goes sine A, cos B. Then cos A, sine B. Cosines are different. They're cos A, cos B minus sine A, sine B. Okay, let's evaluate. Let's first do the pi over 6s. Which side of the hand is the pi side? Palm. Look at the palm of your hand. Pi over 6 represents which finger? Ring. Bend your ring finger, flip your hand over. For the cosine, how many x fingers do you have? 3. And it's always over a radius of 2 on the hand trick. Okay, while we're on that spot, let's go to sine pi over 6. We already flipped, so the sign is gone. What do you get for the sign there?
1. That's square root of 1.
Perfect. I'll pull down that minus. This is a times, this is a times. Okay, now let's go back and let's reevaluate 5 pi over 4. Don't forget 5 pi over 4, we're going to have a negative x and a negative y. 5 pi over 4, which finger is our pi over 4 finger? Middle. Bend your middle finger, flip your hand. How many x fingers do you have there? Square root 2 over 2. And here? Square root 2 over 2. Okay, because we're in this third quadrant, what could you tell me about the x value? That's a negative, and this y value. They're both negative. Okay, let's simplify. They both have a denominator of how much? 2 times 2. What's 2 times 2? 4. With square roots, you cannot add or subtract them, but you can multiply them. What's square root of 3 times negative square root 2? Negative square root 6. Now minus, what's square root 1 times negative square root 2? That's minus negative square root 2. Well, what happens when it's minus a negative square root 2? It actually becomes a positive. So it's the negative square root of 6 plus square root of 2. That's actually right there. Shown another way, you could say this minus and this negative cancel each other out because they're multiplying. They cancel each other out, but this one remains. That's why it's negative square root of 6 plus 2 over 4. That would be your answer there. Okay, now that I've shown you that formula, you can try number 7 on the back of your packet. All right, example 4. So now we get to start playing around with some things to help you understand how to solve this. It says, suppose that sine A is 4/5 for a quadrant 2 angle, alpha, and sine beta, or B, is 1/2 for a quadrant 1 angle B. Okay, so let's think through this through. Sine is like which on a unit circle? Sine is what variable? Y. So the Y would be like 4/5. So normally we would draw a line straight across, but this says it is quadrant 2. So I'm going to draw to this point right here. Does that make sense? I'm going to go from 4/5 straight across and say that's where that angle would be. Let me use a tool so I draw a straight line. Just want to make sure everybody's kind of following along with what I'm doing. So it'd be like through there. That is your A. That right there would represent angle A, or alpha. I'll actually try my best to do an alpha symbol here. Alpha, that would be alpha right there. This is 4/5 on the Y value. Let me put, sine alpha equals 4/5. That's what I did there. That's its line, and it takes me to that point right there. Let me just do it the way I've been doing it, with the line all the way through. Are we cool there? Okay, now, it says sine beta is 1/2. So what is sine again? Y. So we go to the Y, and from halfway, which is about here, you go across. This time I go to the right. Why do I go to the right? Because it's quadrant 1. This is where sine beta equals 1/2. So this one, let me get an intersection. This would be angle beta. If you were to draw it, beta would be this angle right there. That is beta. That's how the drawing would actually look. Sine B is the Y. B by itself is that angle there. Okay, here's the question. I just kind of drew this out. Find the exact value of each of the following. First, if I want to know cosine of alpha plus beta, well, you have to know your formula. What do you remember? This is a cosine sum, or a sum identity for cosine. Do you remember, does cosine stay the same, or does cosine change? Changes. So it's going to be, remember, cosine goes cosine, cosine. So cosine A, cosine B, and the symbol changes. Times sine A, sine B. Remember, it goes for cosine, it goes cos A, cos B. Change the symbol. Sine A, sine B. That's what happened. Oh, I messed up. I need to change the symbol. Sorry. There we go. Are you all following now? Okay, to solve this, I'm going to do a triangle. Come back over, and I'm going to draw both of them as a triangle. This is going to be triangle alpha. This I'm going to call as triangle alpha. And then I'm also going to have over here triangle beta B. On triangle alpha, they told us our Y value. What's our Y value here? 4. That's like the radius. So come over the radius, but the radius is 5. X. Y'all probably remember this triangle from geometry. This is a blank 4, 5 triangle. Do y'all remember what number it has to be? No, we got to do the Pythagorean theorem if you don't remember. X squared plus y squared equals r squared. In this case, we don't know x. Y is 4, which 4 squared is going to be 16. R is 5 squared. We have x squared plus 16 equals 25. What's my one step of algebra I got to perform here? We subtract 16 on both sides. And so x squared equals 9. How do you get rid of a square? Square root. Now, we would normally say 3, but directionally, this is negative 3. So even though the square root would be 3 there, we're going to put it negative 3 there. Why negative 3? Because it's quadrant 2. Very good. Okay, we'll use that to fill in. Now I'm going to go do triangle B. What do I know about triangle B? I know the y value. What's the y value? 1. What's the r value? What am I missing? X. How do I find the x? Plus y squared equals r squared. We don't know x. We do know y. We do know r. So this will be x squared plus, what's 1 squared? 1 equals, what's 2 squared? 4. What's our one step of algebra? We subtract 1 on both sides. So x squared is 3. If x squared is 3, we now take the square root, and do we have a good square root of 3? No, I forgot to cancel over here. Those cancel. And so we're left with x equals square root 3. Okay, would it be positive or negative square root when you go to the picture? Positive, because it's going right. Okay, so this says cosine alpha. You look at the alpha triangle. Let's call alpha right here. I'm going to call that alpha just to make it simple, and I'm going to call this one beta. You look at the alpha triangle. Cosine is x over r. So what's my x? Negative 3. What's my r? 5. Times cosine b. So you look at triangle B. What's cosine's ratio? X over r. So it'd be the square root of 3 over 2 minus sine A, 4 over 5, times sine B, 1 over 2. We can simplify that. When you multiply all the way across, they have a common denominator. What's my denominator all the way across? What's my denominator here? 10 and 10. Negative 3 square root 3. You cannot add and subtract square roots, so I'm going to just leave it like that. Minus, what's 4 times 1? 4. That's my answer right there. Very weird answer, but that's what it is. Okay, the next one's going to go a whole lot faster because we have all this work already done. Sine A plus B. What's the formula for sine A plus B? Help me out. Does sine symbol change or does it stay the same? It changes. Hey, we've done sine A plus B already. Let's change it to a minus. Let's do a difference. This is a sine difference now. So it would go like this. Sine A. No, you go sine A. Is it sine B or cos B? Cos B. Now sine symbol stays the same. So it's going to stay as a minus, and then it'll be cosine alpha times the sine of beta. Cos A sine B, like that. So let's plug them in. Sine of A. What is sine of A? Over here. What is sine's ratio? 4 over 5. What's cosine B? Square root 3 over 2. Perfect. Minus cosine A times sine of B. Once again, we can simplify. I have a minus and then a negative right next to each other. What happens with those? Those are going to add. So it's going to be, I have a common denominator of 10 all the way across. Common denominator of 10. It'll be 4 square roots of 3 plus 3 times 1. What's 3 times 1? 3. So if you were to add these two angles together, like it asked us to do, the sine value would be positive. The x value would be negative. That means we're on the left side, but still up above. If you added this angle and this angle together, if you took that, you'd be somewhere over here, I think. I'm trying to measure this amount of radius to this. You'd be somewhere over here. That's why x was negative, cosine's x, and why the sine is positive. Okay, last one. What if it said cosine 2a? This is called a double angle. I'm going to show you how this works. This is a double angle. Why is it called a double angle? What I want you to think of this is the same thing as cosine of, here's how you do double angles, a plus a. What is a plus a the same thing as? If you had an A and you add another A, what does that equal?
8.
2A. So that's what I'm going to do here is just, you're going to memorize the same formula. It's the cosine sum formula. Just think of 2A as being A plus A. What do you do for cosine's formula? Does cosine symbol stay the same or does cosine change? It's going to change. So remember with cosine, you go cos, cos. So cos, cos. Change the symbol. And then we do sine, sine. Very good. Sine, sine. So I'll plug in my numbers. Cosine alpha, we've done this now a few times. What's the cosine? Negative 3 over 5 times cosine of alpha, negative 3 over 5, minus sine of alpha, 4 over 5, times the sine of alpha, 4 over 5. Very good. We have a common denominator all the way across. What's our 20? Oh, what's our 25? What's our common denominator? Going to be 25. I have a negative 3 times a negative 3. When you multiply those become positive. What's negative 3 times negative, or positive 3 times positive 3? 9. Minus, what's 4 times 4? And that can actually reduce since I don't have a square root. What is 9 minus 16? Answer negative 7. It's negative 7 over 25. That would be the answer there, part C. Okay, you see me do this a bunch. That's practically how to work that out, how to combine things together. Go try D-Wells 9, 8, 6, 4. You now learn most of the lesson right there. Try D-Wells 9, 8, 6, and 4. All right, example 5 and following. These are, I'm going to call them just kind of extra practice, extra problems the rest of the way. We shouldn't be seeing too much that's new. It's just going to be using more and understanding how to use our formula. So first, we're supposed to find solutions in the equations in the interval 0 to 2 pi, and then we'll verify at the end using our graphing calculator. So this right here I see is a sine sum identity. And so the way it works with sine, I'm going to call this here A and this B, is when sine has a sum, you do sine of A times the cosine of B plus, because the sine symbol stays the same, cosine A times the sine of B. Now that's right there. That right there is this first part expanded out, okay? So all of this right here has been expanded out there. So now I need to add, I'll do it black here. I'm going to add, now we have another sign, but this time it's a difference identity. And I'm going to use the letters A and B again. Or if it's easier, I'll say C and D this time. No, that's the same values. There's just a, so I'll go A and B. They have the same X and pi over 3, so I'll leave them. So now when it's a sign difference, the way the formula works is you go sine A, which is X, times cosine B, which is pi over 3. Sine symbol stays the same, so it'll be minus cos X, cos A, times the sine of B. All right, now all of that would need to equal 1. Notice this portion right here came from here. Okay, that's how I've come up with this. So all of that right there became this right there. Okay, so now that I've kind of set that out, I'm going to look through and see what algebra I could perform here. This has a sine x times a cosine pi over 3. This has a sine x times a cosine pi over 3. They're both adding. So I actually, if you notice, here and here, these are common. So those two could come together and become 2 sine x cosine pi over 3's. Now I have a cosine x sine over 3, that's positive, and I have a negative cosine x pi over 3. These would cancel out with one another. So all that's left over now is 1. So those two combined together to give me this right there. Those combined together to give me 2 of those. And so to solve from here, I would divide by 2. And now I have sine x times the cosine of pi over 3. Whoops. Pi over 3 equals 1/2. Now what I'll do next is I'm going to evaluate cosine pi over 3. So I'm looking at the pi side of my hand. Pi over 3 is my pointer finger. I flip my hand over and I get 1/2 there for cosine. So now I have that sine x times, this would be the square root of 1 over 2, which is just 1/2, equals 1/2. That was evaluating cosine of pi over 3. Now, what I would do algebraically, if I'm multiplying 1/2, you could say divide by 1/2, but with fractions, it's easier to say to multiply by the reciprocal. So I will multiply both sides by 2 over 1. And this, basically this 2 over 1 cancels this 1 over 2. So you're left with sine x equals, and again, they would cancel over there, but just to make sure you understand, 1 times 2 is 2, 2 times 1 is 2, 2 divided by 2 is 1. We need to know where sine x equals 1 on 0 to 2 pi. Sine is y, it only equals 1 at one location. Sine x only equals 1 at the top of your unit circle right there. At this spot, that's where sine x would equal 1, the height of 1 there. Notice that pi over 2, that is your input. Pi over 2 is the input, the output would be the 1. Therefore, pi over 2 is our solution here. If you want to write this out, you would take the inverse of sine, so it would be the sine inverse of 1. And that sine inverse, the arc sine, there you go. That would be pi over 2, and that would be my solution. You would only have one solution because it being positive 1, if it had been negative 1, it would have been 3 pi over 2. Okay, so let's try another one, part B. It says sine of 2x plus cosine x equals 0. So I want to remind you, this is a double angle. And a double angle, it's easier to think about it as sine of x plus x. X plus x is 2x plus the cosine x equals 0. So if I wanted to find the cosine of this double angle, it would be sine, whoops. This would become sine of A, which I'm going to call that A. I guess it really doesn't matter. I'll call it like that because they're both x. So it's sine A times the cos of B. Sine symbol stays the same, so it would be plus cosine A times the sine of B. So this right here has been expanded to form that. Now the plus cosine does not change, equals 0. When I observe these two, I notice that these two values are exactly the same. This is a sine times a cosine. This is a sine times a cosine. So this becomes 2 sine x cos x plus cosine x equals 0. Now I'm still on algebra here, still solving with algebra. Notice both terms have a cosine, so you can factor it out. You can do a GCF. That's what I'm going to do here, GCF. And so I factor out the cosine, and I'm left with 2 sine x plus 1 equals 0. And now we can use the zero product property to solve from here. So if you've forgotten the zero product property, what that means is if you're multiplying and you get a product of 0, that means one of these factors here, either cosine or the factor 2 sine x plus 1, has to equal 0. So the way to solve it is you set up that cosine x equals 0, or the other situation, 2 sine x plus 1 has to equal 0. And we're going to solve from there. Now cosine x, I'm going to use the unit circle over here that I provided. Cosine is x. There are two spots. Here's the x-axis where x would equal 0. They're here and here. And you can see that those would, if cosine is x, and you have an x value of 0. Let me go ahead and write that in. That's cosine x equals 0. There's two possible inputs of x that would generate that. It would be here pi over 2 or 3 pi over 2. So here x would equal pi over 2 or 3 pi over 2. Now if 2 sine x plus 1, I never completed this, equals 0, you need to do a couple steps of algebra. We'd subtract 1 first. So 2 sine x would equal -1. You would divide by 2, divide by 2. And so sine x would equal -1/2. And again, using the unit circle provides sine is y. When y is -1/2, it's approximately right there. So if I go ahead and add in this line, let's go through here. If sine is -1/2, sine x equals -1/2, that would have two solutions. That would be 7 pi over 6 and 11 pi over 6. You could do your inverses if you wanted to. 7 pi over 6 and 11 pi over 6. And we were supposed to write all answers on this interval of 0 to 2 pi. So all answers entirely would be going in order. Pi over 2 came first. Pi over 2, looking at the unit circle, I'm going to order here. Pi over 2, followed by 7 pi over 6, followed by 3 pi over 2. I'm going counterclockwise, starting from 0 around, and then finally 11 pi over 6. Those would represent all solutions. So that's how you do that. Now moving on, I have a whole bunch more problems. Again, just extra practice here. What about sine x minus cosine x equals 1? Okay, now I'm looking at this. This one seems pretty tricky because I don't have any squareds. These are in the sine family. What do I do here to proceed? What I need to do in this one is when I have sine x and cosine x together and I can't factor anything, what you need to do is actually get to the Pythagorean identity, which means I need to get these squared. So in math, if you square, you can't just square individually, you have to square the entire side. So that's what I'm going to do first. So this becomes sine x minus cosine x times sine x minus cosine x. And I'm writing it this way so I FOIL properly. This would equal 1. So when I multiply sine times sine is sine squared. That's the first times first. Now outside times outside, that's a negative sine x cos x. And then here I'd have a negative cos x sine x. Well, I'm going to switch the order so you can see that they are the same, minus sine x cos x, because multiplying order doesn't matter. And then finally, a negative cosine times a negative cosine is a positive cosine squared x. Now, that might not seem like it did much, but this right here is a Pythagorean identity. That's sine squared plus cosine squared equals 1. We had earlier that sine squared theta on the chart plus cosine squared theta equals 1. And so what I'm going to do here is I'm going to substitute in 1. These two, I want you to notice, these are the same. So I have -2 sine x cos x. These two become a 1. So it's like 1 minus that equals 1. Subtract 1 from both sides. So -2 sine x cos x equals 0. I can now divide by -2. Divide by -2. Which means sine x times cosine x has to equal 0. And the only way that happens by the zero product property is that either sine x equals 0 or cosine x equals 0. So sine x equaling 0, that's when sine, the y's are 0, that would be there and there. Cos x would be here and here. It looks like there are going to be 4 answers, and we need to check these in a moment, because whenever you square something that wasn't originally squared, sometimes you can create fake answers or extraneous answers. Oops, that was an x, not a theta. So we have 4 solutions. It appears right now here, there, and there. So it appears to me that for sine x equaling 0, it's y here, you'd have 0, pi, and I could include 2 pi and call it 5 answers. For cosine x, you would say pi over 2 and 3 pi over 2. Therefore, on the interval 0 to 2 pi, but not including 2 pi, you would say 0. It's first pi over 2, pi, 3 pi over 2. That would be on the interval 0 to 2 pi. Now, this problem is tricky. What I'm going to show you now is what I have not done is what the problem said we could do is to verify using a graphing utility. What that means is we could come to our calculator, and I'm going to delete what I have on here real quick. And if you just start typing these into sine x, each graph each side here, sine x plus pi divided by 3 plus sine of x minus pi divided by 3. And I'm going to put a y equals in front because technically it should have a y equals. And then you do y equals the right side, which in this case is 1. And we're looking only on the interval from 0 to 2 pi. It says right here. So I'm going to add in a restriction from 0, which is less than or equal to x, which is less than 2 pi. You'll see that we only have one solution. There it is. It's that is pi over 2, which, let's see, is that what I got originally here? Yeah, pi over 2. That would be my one answer right there. That would be it. Let me go ahead and just snap that so I have it for the notes. Okay. If I wanted to try B, if I wanted to make sure that was right, part B, I would do sine of 2x, oops, 2x plus cos of x. Again, we're looking only on that interval, and I need it when it equals 0. The answers I see here, pi over 2, 7 pi over 6, 3 pi over 2, and 11 pi over 6. Those would be my solutions this time. And once again, that was exactly what we had before on part B, if you remember that. And now let's finally do C here. We started with sine x minus cosine x, sine x minus cosine x. We need it to equal 1. And what I was saying earlier is whenever you square a problem that's not originally squared, you have to check for extraneous solutions. And it looks like we have some extraneous solutions. Pi over 2 and pi would be the only real solutions here. My other ones would be extraneous, which just means mathematically we thought they should work, but they actually don't. Whenever you square, usually you create double the answers. So the actual answers, 0 would be extraneous, and 3 pi over 2 are extraneous. And so you'd be left with just those two answers. Should have marked it out from here. So extraneous, extraneous, and extraneous. All of those were extraneous and solutions. So to make my answer look a little cleaner, let me just clean that up. Get rid of that. And well, let me slide over that. No, well, just put x equals right here. There you go. All right, let's try example 5 here. We have cosine of 2x plus 3 sine x minus 2 equals 0. Okay, I want to start here with this part here. We have a double angle, so that's the same thing. Just remember that's the same thing as cosine of x plus x. So with cosine, remember it's cosine A times cosine B minus, because the sign changes, cosine symbol changes, sine A, sine B. That's what that turns into right there. Okay, those two are alike. Now 3 sine, I'm just going to put this right here, plus 3 sine x minus 2 equals 0. You don't have to have the parentheses, but I'll include it there. So it looks like I have a cosine squared x minus sine squared x plus 3 sine x minus 2. Cosine squared, if you remember from the Pythagorean identity, I didn't put that. That is cosine of 2x. Now from the Pythagorean identity, we have that cosine squared theta plus sine squared theta equals 1. You could algebraically rearrange this and you could find that cosine squared theta is equal to 1 minus sine squared theta. And so that's what I'm going to do here, except I'm going to use the letter x. I'm going to exchange this. I'm going to substitute this value right here and say that is 1 minus sine squared x, and I'm going to keep the rest. This changes where I'm all in on signs now. This needs to be equal 0. This equals 0 here. Okay, continuing on, I can combine some like terms. I have 1 minus 2. That becomes negative 1. So negative 1. Let me change colors. So I'm combining 1 minus 2, and that's a negative 1. I'm minusing right here. sine squared twice, so it's minus 2 sine squared x plus 3 sine x equals 0. What I'm going to do now is this is going to be one where I X method this problem. I'm going to write it in terms of a first. I have a you know what, I might just move it over this way so you think of it. I'm going to add it across here. And so I'm going to put the 0 on the other side. I'm going to say 0 equals, if I move the negative 2 sine squared across, it becomes positive 2 sine squared x. If I move the 3 sine x across, it becomes negative 3 sine x. And then moving the negative 1 across, it becomes a positive 1. That'll just make my X method easier. That right there is in the terms of ax squared plus bx plus c. I know it's not just an x, it's a sign, but we can still X method. It's factors of a times c, which is 2, that add up to b, which happens to be negative 3. In this case, negative 2 times negative 1 would give me that. So I could rewrite this out as 0 equals 2. Remember, when your a is 2, one of these is going to get divided out. So it's going to be 2 sine x minus 2 times 2 sine x minus 1. That's how that factors out. You can notice that the first parenthesis is the one that can be simplified. 2 can go into both 2 sine x and 2, so that'll be simplified. And so it'll be zero product property from there. Okay, those will simplify out. Just your a is 2, you can't have 2 2s, so that cancels that out. And so to simplify this one, that becomes just a 1 right there. Like simplify. Zero product property, I'm going to say 0 equals sine x minus 1, or 0 equals 2 sine x minus 1. I add 1 on both sides of both problems. And the first solution we come up with over here is that 1 is equal to sine x. I can add that to the unit circle. We can see that sine x is y. So I go to the y at 1. That's right there. Sine x equals 1. That provides one solution, this one right here, at pi over 2. So x would equal pi over 2 there. And now this solution here, we add the 1. We have that 1 equals 2 sine x. And then we would divide both sides by 2. And so 1/2 equals sine x. This will provide two answers that come up here. Sine is y is 1/2 right there. That is sine x equals 1/2. Sine x equals 1/2. Notice we have two new solutions. We have 5 pi over 6 and pi over 6. This is pi over 6 and 5 pi over 6. Combine them together, we have our three solutions going in order. It would be pi over 6 from 0, followed by pi over 2, followed by 5 pi over 6. Again, you could check these or verify by graphing. Calculator, how you could use your calculator to solve those is you graph these two equations, the y equals the left, which would be cosine of 2x. I don't want you to forget this part right here is a restriction. It just cuts off my graph. Plus 3 sine x minus 2, and that needs to equal 0. And it appears that my solutions would be those three solutions, which are pi over 6, pi over 2, and 5 pi over 6. So we did do that correctly as well. Now we could keep going, but I feel like I've done enough. There's two more here. Go ahead and try DOLs 1, 2, and 5 on the back of the packet. DOLs 1, 2, and 5. In conclusion here, if you know your trig ratios, that sine is y, cos is x, tangent is y over x. If you know your Pythagorean theorem and the sum and difference identities, it's not too difficult to derive many of the other identities. And we talked about this today, so I'm not going to write it in, but you can check your notes and I'll have it completed in. With that, go and submit all your answers, please, to lesson 3-12.